Welcome to our deep dive into the world of AI.
AI.
Artificial intelligence.
That's right.
We're going to trace its path, from just an idea to the force it is today.
Yeah, it's really remarkable when you think about it, how AI has gone from, science fiction to something that's transforming every aspect of our lives.
So we're going to look at the big moments, the turning points, and even speculate a little bit about where AI might be going.
Yeah, and it's not just about the technology itself. It's about how our understanding of intelligence has changed along the way, you know? It's like this mirror reflecting back on us, how we define thinking, both for machines and for ourselves.
So let's rewind way back to the beginning, the 1940s and 50s.
Okay.
World War II had just ended, and the idea of a machine that could think was pretty radical.
It was. It was the dawn of the computer age, and you had these pioneers like Alan Turing, a brilliant mathematician codebreaker, who asked this fundamental question, can machines think?
So that's where it all began, with that one question.
Well, he didn't just ask the question. He wanted to figure out how to measure something as complex as thinking. That's where the Turing test comes in.
Oh yeah, I've heard of that.
Yeah.
But how do you test if a machine is actually thinking?
It's not about looking inside the machine, it's about its behavior. Can a machine act so intelligently that a person can't tell it apart from another human?
So it's not about perfectly copying a human brain. It's about whether a machine can behave as if it has one.
Right. It's like if it walks like a duck and talks like a duck.
Maybe it's a duck.
Exactly. And Turing didn't just stop at the theory. He inspired some of the very first AI programs.
Oh wow. Like what?
Well, there was the logic theorist, which could prove mathematical theorems. And then there was the general problem solver, which could tackle all sorts of problems. It could play chess even.
So these were the first signs that AI could actually work.
They were like the sparks that ignited this whole field. It showed that computers could reason, solve problems, play games even, things that we thought were uniquely human.
Okay, so we've got this big question. Can machines think? We've got a way to test it. We've got these early programs showing some real potential. What happened next?
Well, the next big step was the Dartmouth Conference in 1956. It's considered the birthplace of AI as a field.
Why was that conference so important?
It brought together all these leading thinkers in computer science and mathematics, and they actually gave the field its name, artificial intelligence.
So that's where the term AI comes from?
Right there at Dartmouth.
Yeah.
And they laid out this vision, that AI could potentially revolutionize every aspect of human life. They believed that machines could be programmed to mimic human intelligence, focusing on problem solving and things like playing games like chess.
So it sounds like things were really starting to take off.
It did feel like the start of something big, but there were some bumps in the road ahead.
Bumps? What kind of bumps?
Well, AI went through what are known as AI winters.
AI winters? What does that even mean?
It's like a period where the initial excitement fizzles out. People get disillusioned, progress slows down, and funding dries up.
So it's like a technological ice age.
Exactly. And there were a couple of these AI winters, and they happened because the technology just wasn't quite there yet. You see, computers back then just didn't have the power.
The processing power.
Yeah, the processing power to handle the really complex stuff that AI needed. And data, which is like the fuel that powers AI today, was really scarce.
Ah, so it's like they had the vision but not the tools.
Exactly. It was like trying to build a skyscraper with only a hammer and a few nails.
So what happened? Did everyone just give up on AI?
Well, not completely, but things definitely slowed down. Governments and investors got skeptical. The revolution everyone was hoping for seemed like a distant dream. But AI wasn't dead. It was just waiting for the right conditions to reemerge.
So it was more like hibernation than extinction.
It's a good way to put it.
So what brought AI back to life? What thawed out that AI winter? We'll find out right after this. We were talking about those AI winters when it felt like AI had hit a wall.
Right.
But then things turned around.
They did.
What happened? How did AI come back?
Well, a few things happened. One big change was computing power. By the 1990s, computers had become so much faster and more powerful.
So the tools finally caught up with the vision.
Exactly. Computers could finally handle those complex calculations that AI needed.
And there was more data too, right?
Oh yeah, the internet was exploding, and that created this massive amount of data.
Which is what AI needs to learn.
Right. Data is like the fuel for AI. And with more data and more powerful computers, AI research could really start to make progress.
This is where I've heard the term machine learning come in.
Ah, yes. Machine learning, or ML.
ML.
It revolutionized AI. Instead of trying to program every single rule into a computer,
Which sounds really hard.
it was incredibly hard and limited. What machine learning does is it lets computers learn from data.
So instead of giving the computer a step-by-step instruction manual, you just give it a ton of information and let it figure things out.
Yeah, basically, we give it data and an algorithm, and the computer learns patterns, makes predictions, and even gets better over time all on its own.
That's pretty amazing. So what kind of things were computers learning to do with machine learning?
All sorts of things. They were getting really good at recognizing patterns in data. So things like speech recognition, filtering spam emails, even medical diagnosis.
So AI was starting to become really useful.
It was. And one of the most famous examples of this is from 1997 when IBM's Deep Blue computer beat chess grandmaster Garry Kasparov.
Oh yeah, I remember that. It was a huge deal. A machine beating a human at a game like chess.
It was a landmark achievement for AI. Deep Blue could analyze millions of possible chess moves per second. It was learning and adapting its strategy throughout the match.
That must have been incredible to watch.
It was, and it showed the world that AI was capable of things that people had never thought possible.
Okay, so AI was back learning, winning games, and proving itself in all sorts of fields.
Yeah.
But how did we get from those early wins to the AI we see all around us now?
Well, the next big leap was a type of machine learning called deep learning.
Deep learning. I've heard that term a lot, but I'm not really sure what it means. What makes it so deep?
It's called deep learning because it uses artificial neural networks which are inspired by the structure of the human brain.
Oh, interesting. So it's not just about learning from data. It's about learning in a way that's similar to how our brains learn.
Exactly. And with this deeper, more nuanced approach to learning, AI could start to do things that were previously thought to be impossible.
Like what? Give me some examples.
Well, one of the most famous examples is AlphaGo, a program developed by Google DeepMind.
I've heard of that.
In 2016, AlphaGo beat a one-in-champion Go player.
Go! Isn't that the game that's supposed to be even more complex than chess?
It is. Go is so complex that even programming all the possible moves into a computer is impossible. AlphaGo had to use deep learning to learn how to play the game, and it learned so well that it was able to beat a human champion.
Wow, so deep learning is pretty powerful stuff.
It is. And it's not just about games. Deep learning is what powers a lot of the AI that we use every day. Things like voice assistants, like Siri and Alexa, personalized recommendations on streaming services, facial recognition on our phones.
So it's everywhere.
It really is, and that's just the beginning. We're now entering the era of generative AI.
Generative AI. I've heard that term too, but I'm not really sure what it means. What is it?
Up until now, we've mostly been talking about AI systems that can analyze data, make predictions, or play games. But generative AI is different. It's about AI that can create things.
Create? Like what?
Well, all sorts of things. Human-like text, realistic images, original music, even computer code.
Wait, AI can write code now?
It can, and it's doing it right now. There are all these new generative AI tools and applications coming out. Things like chatbots that can have conversations that are eerily human-like image generators that can create photorealistic images from just text descriptions.
This is amazing. It
Yeah.
feels like something out of science fiction AI that can create.
It is pretty amazing, and it's changing the world in all sorts of ways.
So generative AI is the latest chapter in the AI story, but I have a feeling this book is far from over.
You're right, we're just at the beginning of what AI can do.
Where do we go from here? What does the future hold for AI?
That's the big question, isn't it? And it's one that we'll dive into right after the break.
We've been talking about some pretty mind-blowing stuff when it comes to AI. Especially with deep learning and generative AI, it really feels like AI is changing everything.
It really is, and we're just getting started.
So where do we go from here? What's next for AI?
Well, that's the big question, isn't it? There are so many possibilities. But I think there are a few paths that are particularly interesting and important.
Okay, I'm all ears. Lay it on me. What are these paths?
One path leads to something called artificial general intelligence, or AGI for short.
AGI. I've heard that term before, but it sounds pretty futuristic. What exactly does it mean?
It means creating AI that has the same cognitive abilities as a human. An AI that can learn and perform any intellectual task that a human can.
So not just beating humans at chess or writing code, but actually thinking like us.
Exactly. It's about creating AI that's not limited to specific tasks, but can truly understand reason and learn in a way that's comparable to humans.
That sounds both incredibly exciting and a little bit terrifying. Is that even possible? Creating an AI that's as smart as we are?
That's a question that's been debated for decades. Some experts believe AGI is inevitable, while others are more skeptical. But the research is definitely pushing in that direction.
It makes you wonder what would happen if we actually created an AI that was as smart as us, or even smarter.
It's a big question. And it brings up all sorts of ethical and philosophical issues. That's why another important path for AI is about ensuring that AI is developed and used responsibly.
So it's not just about making AI more powerful, but also about making sure it's used for good.
Exactly. We need to think about things like bias in AI algorithms, the potential impact of AI on jobs, and how to ensure that AI benefits all of humanity, not just a select few.
It sounds like the future of AI is about a lot more than just technology. It's about society, ethics, and even philosophy.
It really is. AI is going to touch every aspect of our lives. So it's important to have these conversations now and to make sure we're steering AI in the right direction.
Okay, so we've got AGI and responsible AI. What else is on the horizon?
Well, there's one more path that I think is particularly exciting, and that's quantum AI.
Quantum AI. Okay, now we're really getting into the future. What is that?
Quantum computing is a whole new type of computing that uses the principles of quantum mechanics. It has the potential to be exponentially faster than traditional computers.
Exponentially faster. That's hard to even imagine.
It is. And when you combine the power of quantum computing with AI, you get quantum AI.
So what could we do with quantum AI?
The possibilities are pretty mind-blowing. It could revolutionize fields like medicine materials, science, drug discovery, financial modeling, climate change mitigation. The list goes on and on.
It sounds like quantum AI could unlock solutions to some of the world's biggest problems.
It has the potential to, and that's why so many researchers are excited about it.
We've covered a lot of ground in this deep dive into AI. We've gone all the way from those early theories about thinking machines to the incredible things that AI can do today, and the even more incredible things that it might be able to do in the future.
And I think the most important takeaway is that the AI journey is far from over. It's an ongoing story, and we're all part of it.
That's a great point. The future of AI isn't predetermined. It's something that we're all shaping together through the choices we make and the conversations we have.
Exactly. It's up to all of us to ensure that AI is used to create a better future for everyone.
That's a great note to end on. Thanks for joining us on this deep dive into the world of AI. It's been an incredible journey, and I can't wait to see what the future holds.